All right, in this video, we're really quickly going to go through an alternative method of division that's a little more advanced technique. You usually learn it in Algebra 2, but I'm going to show you it so that you're aware of it. We like to do extensions for our junior high Algebra 1 students. So the thing we're going to look at here is called synthetic division. So it's an alternative to the other two methods that we've discussed, which were long division and our more preferred model, which is the area model for division. So synthetic division is really elegant and really neat, but it has some very important limitations. So the area model we saw in the last video can be used with any polynomials of any size. There's really no limit to how we can use it. We didn't even divide by a divisor of degree higher than 1. But for example, we could, with the area model, divide by like x squared plus 2x minus 3 and divide by an order or a degree 2 polynomial. It would be no problem. We'd go through the exact same process as we did when we divided by a binomial. So synthetic division can't do that. So there's two very important limitations that if you're going to try this, that you're aware that these exist. So the divisor must be of degree 1, meaning you can only divide by something like x minus 3 or x plus 4. You can't divide by x squared, anything, or bigger. So that's really important limitation the other methods don't have. And the other limitation is we should only use it if the x coefficient is 1. That's not strictly required, but it's like a nuance. I'll explain it if we get a chance in here, but it's just more complicated if you use this when there's something in front of the x. So if you had like 2x minus 3, it's not as good for that, and I would just say don't use it for that until Algebra 2. I'll show you why if there's an example that lets me, but I'm going to pick up kind of where we left off in the last video with this homework page. Or not homework page, with the second part of the notes, and we're going to do a few of these problems using synthetic division, because you'll notice that in here all of these divisors are order 1. We won't be able to use it here either, where we have a monomial divisor, but we can use it for most of these. So I'm going to do it kind of side by side for the first one with the area model. So if we do x plus 10, I'm doing the problem number 1 here, and we divide that into 2x squared. We put 2x up here, 20x here. Then we take that 20, and we need to get down to 7, so we need minus 13x. We put minus 13. We get negative 130. We are at the end of our boxes, and we need that negative 130, the constant, to actually be negative 30. So our remainder is going to be 100 in order to get from negative 130 up to negative 30. So that's how we do that with the area model, and we got the answer 2x minus 13 plus 100 over x plus 10. Now, using synthetic division, first of all, we set up our divisor slightly differently. So we're thinking about x plus 10 equals 0 and asking what would x be to make that work. So we would subtract 10 and get x equals negative 10, and that becomes our divisor. So it's basically the opposite sign of what the actual divisor is. We're going to put that negative 10 here and put a little box around it. And then we write out our polynomial with only the coefficients. We skip all of the x's. So I have 2x squared plus 7x minus 30. And I mentioned in the last video that we leave a 0 if there's a missing spot for multiplying. It's absolutely crucial in this that you leave a 0 for the coefficient if there's a missing term, or everything will break down. So that's another warning of the nuances of this. It's a little more advanced. So to use synthetic division, we bring this 2 straight down to here. And you may kind of recognize that as being, since we always are putting 1x here, whatever number we had here is the same. These match. So the 2 we bring straight down. Then we multiply by our -10 divisor and put a -20 in the next column. We add these two numbers. 7 plus -20 is -13. Then we multiply that -13 by -10 to get positive 130. We add -30 and 130, we get positive 100. Now, this last one is a remainder if there's anything there. If it comes out to be 0, then that means it divided evenly and there's no remainder. So think of this as the remainder column, the constant column, and the x to the first column. So our result here is 2x minus 13 plus the remainder 100 over x plus 10. So we got the exact same answer as we did with the area model. But this one, once I'm not explaining every little step, is very, very, very fast. And you can use it on large degree polynomials as long as your divisor is still a first degree. So I'm going to go through a few more of these without explaining all the detail and just show you how it works so that you can maybe see and appreciate how efficient it is, because it's super efficient. So number 2, we are dividing by -2 because it's the opposite of what is in our divisor. We put our coefficients 2, 7, -30. Wait, that's the same exact problem. Oh, we're dividing by a different thing. That's fine. So we bring down the 2, multiply it by our divisor to make -4. Add those, we get 3. Multiply by our divisor, we get -6. So remember, we're multiplying by -2 each time to come up here. Add those, we get -36, so that's our remainder. This is our constant, and this is our x's. So our answer here is 2x plus 3 minus 36 over x plus 2. The next one, we would do 4 as our divisor because we had x minus 4 here. We're going to put our coefficients that are 1, -12, and 32. We bring down the 1, multiply it by 4 to bring it up here. Add those, we get -8. Multiply that by 4, we get -32, and we end with 0. That means we had no remainder, and the answer divided evenly and was x minus 8. So hopefully, as I'm doing these a little faster, you can see it's really quick and really nice. I kind of want to go back to one that we started with last time, so let's look back at one of these more complicated ones. I'll just do it above here. And maybe we can compare. So looking at what we did last time over here, let's compare doing, which one was that? That was this one, the one on the left. So let's redo that same one with synthetic division. So we start off with 2 as our divisor, and then our coefficients are 1 for x to the 4th, -6 for x to the 3rd, 0 for x squared, -18 for x, and 4 for the constant. So really important that that 0's there. Nothing will work out right if it's not. So a way to check that is this is a 4, so we should have 5 terms here, or 5 coefficients. The number of coefficients in in the row here should be 1 more than the degree because it's 4 plus a constant. Okay, so let's do the dividing. We bring down 1, we multiply that by 2, add those as -4, multiply by 2, -8, add those, -8, multiply by 2, -16, add those, -34, multiply by 2, -68, add those, our remainder is -64. So, since there's more terms here, remember this is remainder, constant, x squared, x cubed, so it just keeps going up. Every spot to the left goes up by 1. So we got x cubed minus 4x squared minus 8x minus 34 minus 64 over x minus 2. So that's the exact same answer that we got originally, and it is much quicker than using the area model even. But remember that it's limited, right? We can only use it certain times. So it's really nice and really cool, but it is not always applicable. So as long as you know when it's okay to use it and when it's not, then it'll be okay. To wrap up, I already feel like I've shown enough that you can get the idea. I want to look at one case. We'll look at this one here, where we're dividing by something in front of the x. So I said up front that that is something that's you can do, but there's issues with doing it. The main issue happens when there's a remainder, though. So none of those are actually good examples of that. That's fine. We'll do this. So if I want to divide 6x squared plus 22x plus 16 by 3x plus 8 using synthetic division, I'm going to first need to put a -8/3 here. No, we can just do -8. That's the thing. We'll do -8 here, and then we'll do 6, 22, and 16. And then we bring down the 6, we get -48, we get -26, we get positive 160 plus 48, so 208. And then we get, no, that should work out. So we do have to do 8/3. See, this is already why we don't want to do this. If the number isn't 1. So we need to do -8/3. And the reason for that is if you think of 3x plus 8 equals 0, and we solved it like we did at the beginning, you would subtract 8 and get 3x equals -8, and then divide by 3 to get x equals -8/3. So 6 times -8/3 is basically 2 times -8, so -16. We add those, we get 6. And then again, 6 times -8/3 is 16. -16, sorry. So -16 has a remainder of 0. But notice here, my answer looks like 6x plus 6. But we saw over here, using the area model, that the real answer is 2x plus 2. And the reason for that is we divided our divisor by 3. So the step we did right here to divide by 3, basically we can't do that because we're just dividing like one expression by 3. We're changing its size. It's okay to divide both sides of an equation by 3, but here we don't really have an equation. So we have to undo that division by 3 by putting our quotient over 3. And then when we simplify that, we get 2x plus 2. So you'll do that in Algebra 2, but for Algebra 1, I would really, really advise that if this number in front of the x is not 1, just don't even use this method. Because if there's a remainder, it becomes even more complicated because you divide the quotient by 3, but you won't divide the remainder. It'll stay as its regular number. So yeah, just if you wanted to use this and try it out, only do it in the cases that we said it was okay, which I erased, of course, but was the coefficient of x in our divisor has to be 1, and the degree of our divisor has to be 1. If you don't have those two things, just stay away from this method for the time being.